Hi, I'm Randall Heyman, a mathematics academic. I've created a number of Corona Help playlists that have quick turnaround videos on primary school, secondary school, and university level mathematics. So if you'd like me to make a video for you or any of your students impacted by the coronavirus outbreak, please just comment below this video or any of my videos, or you can drop me an email to this address here, coronahelpmathematics@gmail.com. Okay, so I wanted to do another proof. So this is proof. This is a harder, I think, than the one I did previously. And the reason it's a bit harder is that it's hard to find a good real life sort of example like we could have in the previous one. So let's have a look at so if you direct your eyes here, let R be a commutative ring. So that's just a ring. The commutativity means that the multiplication can work either way. You get the same thing. So A times B equals B times A. Fix an A fix an A that is an element of the ring. So this is often you'll see them say something like let A be an element of R. In this case, I put fix. You really have to think now where it says let or fix, you really have to sort of think about fixing it. So at this point in my mind, I'm thinking A equals something, I don't know, 17. That's good. But it's fixed. It's not going to change for the purposes of this question now. And then show that this set, which they've called I to suggest it's an ideal, with this little a down the bottom, because it could be, if I fixed a different a when I was doing the problem, then you know, the a would change. So what is it? It's all the x's that are in the ring, where if you multiply by a times x, you get 0. So I'm thinking 17. Okay, so 17 times x has to be equal to 0. But the problem here is it's very hard to think of. You can't use the integers, because the only thing that you multiply integers by, or real numbers for that matter, you multiply to get 0 is the number 0 itself. So it's very simple. It's a single element set. It's not going to really work for you. So I think we've just got to try and keep it general and see how we go. Okay, so let's launch into this. So the first thing, subset. So I would just write that IA is a subset. That's a symbol for subset of R from the definition of IA. Now, you can't always use this for proving something's a subset. This is sort of trivial, and I think most examiners would accept it, but I'll just write here, just if in general, if you want to show that A is a subset of B, well, then your first line is going to be suppose X is an element of A, and then you're going to have all these logical steps, and then down the bottom you're going to have X is an element of B. That's how you do the more complicated subsets, where you've actually, but in this case it's so obvious that I don't think you would require it. Non-empty. So it has to be a non-empty subset. So, 0 is an element of IA since A0 equals 0. Notice here we're not using the multiplication sign or the dot sign. We're just, multiplication is understood where you have two things next to each other like that. So what I'm suggesting here is that up here, whatever A is, doesn't really matter. Multiply by 0, we get 0. And so that shows that it's an element of IA. Just hold on, I'll get some water. You might be a bit queasy about, sorry about that. You might be a little bit queasy or uncomfortable with the fact that we're saying that A times anything times 0 is 0, because we haven't specifically covered that in the definition of rings and groups and that sort of thing. So you might want to go back and you can prove that from the definition of a ring and a group. 3. So here I'm going to do this bit, the A minus B is an element of, that's sort of the summary of what it is, but if you want, that's what I'm looking to do up here. Okay, let's get rid of that one. So if A and B are elements of the ideal or the set of IA, then what does that mean? We better not use A and B here because we've already got another A. So I'll put here, what we're trying to show is R minus S is an element of the ideal. So if R and S are elements, sorry, little A there, what does it mean if they're elements of IA? Then AR equals 0 and AS equals 0. I'm just following the rule that's in the set I little a. So AR minus AS equals 0. Thus, now we're using the distributive law, which is part of one of the rules for a ring. So R minus S is an element of IA. That's good. Let's work there. And now the fourth one. So just before I roll up, let's rub that out. And the fourth bit is this bit here. So let's go about and prove that. So I'll just say RS equals, I've used here R. Okay, well here I've used R is one element of the ideal, but generally I've been writing R is an element of the ring. So that's a bit confusing, but that's life in the big city. So I'll just put here, I'll actually just put what I wrote in the definition. So maybe in fact I'll just use completely different letters, say C and D. Let's see. So here, remember, the way this works is we've got an element C of the ideal, and we've got an element D of the ring. So what does it mean here for C to be an element of I? It means that so that means that AC equals 0, because that's what follows from if C is an element of I, that must follow. So that, and then, so let's rub that out and go then, not R, we're using D for the element of the ring. So D is the element of the ring, and I'm going to multiply it by AC, and I'll get D times 0. I just multiplied on the left-hand side by D, and that actually, I can just write that equals to 0. Since it's a commutative ring, what follows, DAC equals A DC equals 0. So all I've done is just change the order to get ADC. And now this is in a form where hopefully we recognise that and thus DC is an element of I. because we've got this thing that when we multiply A by it, we get 0. So that also, well, we've just said it's commutative. So CD, DC is equal to DC. So CD is also an element of I. So we've done what we wanted to do. So there's a fair bit here. Not that easy for people who are new to all of this. So therefore, I better put A's, little A's here, of course. So IA is an ideal of R. So I hope that's helped you with something that's a little bit more abstract than the one I did before. If you've got any questions on this, or in fact any area of mathematics, feel free to comment me or email me.